All right, we're going to show that x to the n minus 1 equals that bracket. So let's actually look at the right-hand side. If I look at the right-hand side, I've got x minus 1 times this, and then x minus 1 times this, and then x minus 1 times that, etc. So why don't we do that? So we've got x to the n minus 1 times x minus 1. We've got x to the n minus 2 times x minus 1. We've got, let's go right to x squared, x minus 1, and we've got x minus 1, and 1, x minus 1. So if we expanded that out, we'd get x to the n, if we do like these two, and then minus x to the n minus 1. Then we'd have plus, again, these two would give us x to the n minus 1, whoops, and then we'd have minus x to the n minus 2. So you can see each time these two terms are cancelled. These next two terms would cancel. Over here, let's say dot, 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 we're up to here. We would have our x cubed minus x squared, and then we've got an x squared minus x, and then we've got an x minus 1. So again, you see these two will cancel, these two will cancel, these two that are in the middle of the dot, dot, dots would cancel. So the only terms left are the first and the last. So we've got x to the n minus 1 there. The rest would be zeros. All right. So let's use that. So here we've got 7 to the n minus 1. So using that, so from part, let's say A, we've got 7 minus 1, 7 to the n minus 1, 7 to the n minus 2. We're going to go all the way down to 7 squared, 7 and 1, just using that expansion. So you can see it's going to be 6 times this bracket here. That's all from part A. So you can see clearly that z to the n minus 1 is a multiple of 6. Has to be a multiple of 6. So let's look at a to the n minus a to the n minus 1. So what do we have here? Let's assume firstly that, because you could probably think of a something that would make this false unless we say a is a positive integer. So let's say a has to be a positive integer. Otherwise we could have a minus 2. Anyway, so let's consider a to the n minus 1. So we know from a we can expand it. That's an n minus 1, n minus 2. We've got a squared. Whoops, that's dot, dot, dot. A squared, a, and 1 there. Okay, now we're told that this is prime, so if it's prime, we know its only divisors are 1 and itself. 1 and itself. Now neither of these brackets are itself, because itself is a. A to the n minus 1. So neither of those are itself. Are either of those brackets equal to 1? Well, clearly this bracket can't equal 1. That's 1 already, so it's going to be more than 1. So that this bracket cannot equal 1. So what about this bracket? Well, if that bracket equals 1, then a minus 1 is 1, and a would equal 2. So there we've got, so for where a is positive, a equals 2.